All right, well, why don't we get started? Jamie, if you could introduce, well, first of all, I should say I'm Will Young. I'm the CEO of Aerowave Technologies, and I'm hosting today's webinar on the difference between different voice communication solutions and how to choose what's right for you. I've got Jamie Clay here as my guest. He's our director of operations here at Airwave. So he's the one who has to make all this stuff work when we sell it. So I will let Jamie introduce himself, and then we'll dive into to today's topic.
Yeah, thanks, Will. Again, Jamie Clay, Director of Operations with Aerowave. I've been with Aerowave for just a little over 4 years now. My background prior to coming to Aerowave was in telecommunications, where I had a career of just over 20 years in telecom as engineering and operations leader. So very
Great.
happy to be here today. Thank you.
Um, awesome. Well, we will dive in. Jamie, I think maybe if we can start, and I've got this presentation we can flip through real quick, but maybe you can start by explaining high level the differences in the different voice communication solutions that exist, and
Yeah,
how
absolutely.
maybe how you think through what to get.
Okay, absolutely. The three main solutions, and especially that we'll be talking about today, is your PCR, which is your private commercial radio. It's a very robust system. It's got a wide range of applications and products that are you're able to utilize with that. We'll also be talking a little bit about the P25, which is focused in public safety, first responder type equipment, and LTE, which is utilizing the cellular networks.
Awesome. And so, Jamie, like, kind of, what are the different ways you think about choosing one of these solutions?
Yeah, the main thing when you're choosing a solution and trying to figure out which one is right for your application, you've got it's here on the screen, a few things that you really want to just kind of look into to say which one works for me. Coverage area is always a big factor in this. You need to make sure that you're getting a solution that's going to, obviously cover your geographic area, whether that's like a single building, a single location, multiple locations spread across, different areas, or even just a footprint that's too large for one repeater system to cover. And then you've got other factors that, like the budget. What is the budget on this? Some of the different solutions have a wide range in cost. User requirements, how many subscribers you're going to have on the system using it at one time, or how many different departments. And of course, interoperability. So do you have a big range of equipment that has to communicate and talk together, whether it be different manufacturer radio types, or is it different situations like dispatch consoles, or other devices that need to be compatible and working with these systems or these radio equipments?
Awesome. Well, thank you for kind of going through that real quickly.
Yeah.
So, can you kind of give us an overview of what the different types of radios are here?
Yeah, absolutely. So the handhelds that you see in the top left there, the portable radios, that's going to be your basic digital handheld radio. These there's a very wide range of different products available, in this piece here, but um, the main thing is this is your subscribers. This is somebody that's going to be, out on the floor or moving around property, moving around the building, that they can take this with them. These are, not powerful radios. They typically are going to be 3 to 4 watts. So they have good coverage, but that's where you get into, again, going back and analyzing that to determine, do I need a repeater to increase that coverage. Your mobile radios, that's going to be mounted into your vehicles, whether it be a bus, a utility vehicle, or attach it to a power supply and use it as a base station. If somebody, you've got just one point of contact in a building, like at a front desk, these are very powerful. They're going to reach out a long ways and be able to provide a lot of distance in your coverage. Of course, your push to talk, that's your LTE, that's going to utilize your cellular networks. Those are also available in both types with handheld portables and base stations or mobile devices. And then, of course, your public safety radios, which are going to be, encrypted. They're going to be very high end. Most of them are going to be dual band capabilities, and again, focused on your public safety sector.
Awesome. Well, thank you, Jamie. So I think we're going to dive in next to kind of each one of the different voice solutions with land mobile radio, P25, and LTE. So if you could just give us a little bit, get a little bit of the kind of the pros and cons and use cases for each of these technologies.
Yeah, on your DMR, which is it's gonna fall in that PCR category, but this is going to be something that, best use case in this would be like a school district or a hospitality, construction properties, things of that nature, where you don't have to worry about, going out, long ranges or having a encrypted type secure environment. So this is something, we do a lot of these, especially in the school district area. It's great for, clients that don't want that reoccurring cost. They can use a CapEx budget. You get a upfront cost to it. You purchase your equipment, your system, put it in, and it's extremely reliable. Plus, it gives you that security of having, the privacy of your own frequencies, your own private communication, so you don't have to be worried about that. As you see, some of the pros here is that, again, that upfront purchase cost, that you don't have the reoccurrings after that. They're very customizable, so there's a wide range of products available with this, so we can customize it to whatever this solution is that's needed. They're very expandable. So you can easily, add to it, expand as far as capacity goes. If you find out, hey, I need more channels, it's easy to expand that into adding more channels to it, to going from conventional type, even all the way up to, trunking type systems. Okay, there we go. We lost it there for a second. You can expand it out into linking systems together within this type of equipment. So you can cover multiple buildings, multiple locations, or just create a huge wide area footprint if that's what's needed. They're very redundant, so they're very reliable with different types of backup solutions. You can even get into the tier 3 type radios and systems. You can even build in more redundancy with servers and redundant servers that keeps these systems extremely reliable. They can operate and communicate with other systems as well. And again, just the big product range on this makes them very attractive. Some of the cons on this, as you've got pointed out, it is a high upfront cost. It's very much on the front end of purchasing all the equipment, building it all out. But then after that, then you're set for a very long time with it. You can be limited on geographic area. And what I mean by that is, while it's customizable and you can expand it, you have to continue to add, potentially add other sites to expand that. Whereas when we get into one of the other solutions further in this, we can address that a little bit more, but that's a limitation to this. Programming, that it can become, a little bit cumbersome if you sometimes on it, but it's still, you got some limitations there. And the interoperability of it to it is you're specific to certain bands. But other than that, this is a very great solution for most users. It provides a lot of flexibility in how it's set up. You can build it out to fit a lot of different needs, and it's extremely reliable.
Awesome. Thanks, Jamie. And what's the smallest system that we've done, and probably what's the biggest?
Yeah, kind of the smallest system would be like just a single building, single repeater type setup, just a conventional repeater. which when I say unconventional, I'm meaning it's not trunking, it's not doing anything special there. You just have two channels. So in a scenario like that, that those are really common. We do a lot of those. And you could put, I would say, anything up to approximately 70, 80 subscribers, and that spread out on that. That's a good rule of thumb. Again, that can vary based on the amount of traffic with those subscribers, but just as a guideline. As far as the large system goes, we've gone as far as close to 90 repeaters on a system with a tier 3 setup. So, and also linked together with dispatch consoles in other cities. So very robust.
Yeah, you really can go small all the way up to really, really big, depending on the client needs. All right, next we'll do P25.
P25. So when we start talking about P25, what that actually is, P25, it stands for Project 25, and it's basically a standardized requirements is what it is. And it's been adopted by multiple manufacturers, Motorola, Kenwood, and several others, Tate, many of them. So but P25 it's a requirements list is basically what it is. This is something that's going to be focused for your first responders. So a great way to look at this, if you're thinking about like the county sheriff's department, that's something that needs to be very encrypted, very secure. It's got to have a lot of redundancy and backup built into it. That's where you're going to see something like this in the team like that. It's extremely reliable. They're extremely durable products, but it's a very high cost product as well. So again, you have that upfront capex in the beginning. You can do very large coverage areas with this. Typically, in this type of setup, you're going to see more of a wide area system being built out in most cases with this. They're very, very redundant, and they have to be because of the nature of the communication that's being ran across this, and it's typically always going to be a some sort of safety, security, or emergency scenario where these are being used. So the redundancy is extremely important, and they're designed to be able to support multiple different products and manufacturers to be able to talk across it, as well as multiple different bands too. So. And also it's a very large portfolio of products available for it. Some of the cons as you've got here, Will, is they're much higher in cost than DMR. They often have a lot of reoccurring costs associated to it as well. Getting into the buildings, you've got the BDA and the DAS, which requires also a lot of different build outs to support this, and is very costly also. And then the encryption, when you're talking about encryption, that's makes it, especially when you start going into programming or making any kind of programming changes, those encryption keys make that very, very difficult at times. And they're very, very complex to design and deploy.
Perfect. Thank you, Jamie. And then finally, we've got a long-term evolution, or LTE.
Yeah. So the LTE, and I sort of touched on this in the DMR regarding the range. LTE is you'll hear that a lot with our cellular devices, and that's what applies here in these devices as well. They utilize the cellular network for communication. They're really great for, like if you think about a more of a rural type school district that maybe has buses that travel out a long ways from their main campus that we potentially couldn't reach with even a repeater. This is something that may work well for that if they have good cellular coverage, or a company like a service company that travels all around the metroplex, where there is good cellular coverage, but they're going, several miles out or many miles out on a regular basis, and they're running out of your standard normal radio range. This would be a good product for somebody like that. It's as far as the installation and deployment of it, it's very simple. They have your handhelds and your mobiles. So those, like the mobile radio in this is the same type of installation as a DMR mobile radio in your vehicle. So it's very straightforward, very simple. But one of the main drawbacks of this is it does rely on a cellular network. So if you have, if you're in the area or you're often in an area where your normal cell phone is having issues, then naturally you're going to experience coverage issues with this product also.
Gotcha.
Outside of that, it's a great product. It's it works really well. One of the other great benefits is a lot of these provide additional features with them, so you can get into some dispatch with it. As because of the GPS solutions, it's more real time than what you would get with like a DMR type, because it's getting a cellular feed instead of relying on a data transmission through the DMR.
That's on GPS, Jamie.
Yeah, that's on GPS. So you're able to get a better GPS with this type of product, and be able to pull it up in more of a web-based scenario without having a lot of different equipment attached to it.
Got it.
Yep.
And so just kind of a quick question here is, we talked about each of these as a silo, right? There's three different versions of this, of voice communication technology, right? But how do you, or can you, and how do you, if so, interoperate these things together?
Yeah, that's a great question. So like, for example, your LTE or your in your DMR, there's a lot of ways to bring these type of products together. Some cases use gateways to bring them in, which is probably the most common, using a gateway to bring them in with like a donor type radio, or just in a lot of cases we can do it with just network interfaces, and that's kind of the biggest key to it. As long as you're able to get network interfaces, you can bring this equipment together and make them compatible with each other.
Got it.
In your P25, a lot of that equipment comes, dual band or multi-band, so you're able to do a lot of different programming into it to bring the devices together in those scenarios.
It sounds like it's quite doable to interoperate these things, but you kind of need to plan ahead before you kind of measure twice and cut once here when you're designing your system, to make sure that you get the ability to interoperate these systems.
You hit it right on the head there, Will. It takes a lot of planning on these. You really need to go in and do this is where you really need to investigate with the client and really understand what their use case is going to be, the area they need to cover, how many subscribers and users, and what does it need to interface with. Get a really good understanding of how the client intends to use the system, and then from there we can really design something that fits their needs. But it all starts with that understanding how it's going to be used. Once we get that strong understanding, then we move into engineering and designing a system that fits them, their solution. But yeah, you hit it right on the head. That's what's required.
Awesome. Well, thank you. Just one final question here, unless anybody else has anything. But if I'm interested in buying one of these systems, what's the timeline? From the day I order it until I can get the devices in my hands and using them for my people.
Yeah, that's great, and it does vary based on each of these systems, right? So the faster one to implement, it would be the LTE. That product we could get pretty quickly. We don't have to go out and get frequencies from the FCC frequencies and wait on that turnaround. So these can get implemented relatively fast, within a few weeks or less, depending on stock levels. But again, it requires your cellular network. In some cases, you've got to get SIM cards on them, which kind of falls back into the not being quite as durable and reliable, but fast to implement and lower upfront cost. The DMR would be the next one that would be able to get in. This one, again, you're probably talking, depending on stock levels, anywhere from 3 to 6 weeks, depending on the system size.
And that's for a repeater. That's for a repeater system.
That's for a repeater. For radios, we normally keep the majority of these radios in stock. If we get programming, then we can turn these radios around within a couple of days, program them, get them out to the client. If you're looking at a system where we have to go out and get frequencies, it's doing that discovery up front with the client, understanding what it's going to be, designing it, getting the equipment and the pieces together. Anywhere from 3 to 6 weeks on a turnaround like that. As long as we're not, again, if we're going to that one I was talking about earlier, where we're 90 repeaters across multiple different locations, and it's obviously going to be longer than that. But in most cases, it's going to fit that time frame. And then your P25 is really going to stretch out there. This equipment is much longer lead times. There's a lot more involved in getting it, so it's going to take several weeks into possibly 30 to 60 days, and in some cases maybe even more, depending on equipment availability.
Got it. Well, thank you, Jamie. I don't think we have any other questions today, but if nobody else has anything, then we'll go ahead and wrap up the webinar there. The next webinar we're going to have is on Friday, July 25th at 10 a.m. And this is going to be really focused on getting prep for back to school for our school district clients and private school clients that are getting ready to go back to school, and kind of best practices, things to look for, and ways we can help you guys get ready for school. So thank you, everybody. Have a wonderful weekend coming up here, and we'll talk to you in a couple of weeks. Thanks.
Thank you.